All right, so welcome to our second week on MSE 100, where we're going to build off the stuff that we've been discussing so far. So if you recall, we looked at some of the SolidWorks stuff, and then we looked at a course overview in the last lecture, and then we were able to create drawings and stuff. So this week's lecture, we're going to switch over to actually creating hand drawing or hand, like we'll introduce and do concepts of hand drawing stuff, and then we'll basically kind of try to create some hand drawn objects. So with that, let's switch to our presentation here. So the learning objectives for the day are going to be analysis of constraints in SolidWorks. So then we'll look at introduction to projection, and then we'll do some sketches and projection. So these are going to be the topics for the day. So where we'll quickly recap some of the stuff we did, and then we'll actually look at the number of constraints and how we calculate it and kind of get a conceptual idea of what constraints are and then how they're going to affect your drawing. And then once we do that, we'll do the exercise of rotating the L-shaped object, and then we'll do more complicated projections of different stuff. So quick recap. So the what we basically did last class is we looked at SolidWorks and how we can actually create different objects there. We also mentioned, and then we would be aware that the course actually has two parts to it. One would be creating hand-drawn engineering drawings. So this is again really important because both from a traditional perspective, where if I give you a drawing, maybe that was already created, so you should be able to interpret and then figure out what the drawing actually says. And also from the fact that once you create the drawing and if you have to take it for production, a lot of these sign-offs need to be done on engineering drawing. And then if you're actually interpreting the drawing, you should kind of be able to look at a drawing and then kind of make a good judgment or at least have a basic idea of how the object looks. Secondly, what we need to do is like if you are kind of wanted to quickly sketch some drawing and then send it off for quick discussion, you don't want to power up SolidWorks each and every time. So this again, so you should be aware of how to create simple drawings in SolidWorks. So once we did that, so we actually did some, so we used SolidWorks to create some 3D objects, and then we were looking at how to do all of this stuff. And then again, if you recall, what we talk about as engineering drawing is kind of the standardized symbols that are basically used. And then what we basically do is we kind of, if we want to convey a technical aspect, we kind of have like standardized symbols in the drawing itself that gets communicated. So just like you have a structure to the Indian language, when I say say a particular word, so instead of saying if I hit the ball, so that has one meaning versus the ball hit me has a different meaning. So just as with the language, this is basically an engineering language where the different symbols that are used and the structure of your document kind of would convey different meaning. So we should be aware of that. And then when you're doing all of our drawings, we should take into account the best practices that are used. So let's start with the first topic for the day. So which is basically looking at the number of constraints for a single point in a 2D sketch or number of constraints for points in a 2D sketch. So what we have to remember here is that you're actually looking at a single 2D plane and then we're looking at a point. So we have to ask ourselves, how would I actually define the point? So there are a couple of ways we can actually interpret the constraint. So the first one is what does it take to make sure that the point doesn't move freely if I pull on it? So that's one way to think about the constraint. The second way to think about it is what are the different parameters you would need that if you repeat the process, so for instance, you're making it and then your friend makes the same point, what are the information, how many pieces of information do you need to kind of just repeatedly get the same point or get it at the same location. So that will basically be the defining, or that will be the number of constraints that we use here. So if you think about it, we have to imagine how you define the point. So because we are on a 2D plane, so what do we need to do is if I basically have my origin of coordinates at some point over here, and then I have this point over here. So what I would basically define is I would define kind of the distance along the x direction and the distance along the y direction. So that will give me the point over here. So essentially the way I would define the point is to basically define the x and the y coordinate, or the distance from along the x and distance along the y from some prescribed origin. So that basically means that if I want to fully constrain the point, so for instance, if I basically want to say that like if this is the bottom corner of my video is of origin, and then if I want to constrain the point over here, so if I give you the x distance and then the y distance, you can figure out where this point is going to be. The other way to think about it is if I kind of apply the x and the y distances, I cannot move the point in either of those directions, and then I'm fully constraining that particular point in my sketch. So hence, we basically need two constraints to define the point. So let's look at the other thing. So let's kind of imagine how many points are needed or what does it take to fully constrain a line in a sketch. So think about it. So you can pause the video here and then come back. So most of you are probably guessed this already. This is not that difficult. So if you think about it, so you can have two constraints to define maybe the left side, and then the two constraints to define the right side. And then that basically means if I have to fully define the line, I can constrain each of those 2 points, and hence I end up with 4 constraints. So before you go, you're like, hang on, right? So what happens if I define the slope and then the length of the line? So, right, so that basically means can I just use two constraints to define the line? Yeah, so essentially, so if I have this line, so I say the length is fixed and then the orientation is fixed. So then does that mean I only need two constraints? So the point you need to remember is that if you just define the length and the angle, the line itself can still move up and down or left and right. So what you need to do is kind of constrain one of those points completely. So you have to define two constraints kind of to prevent it from moving along the y and along the x. So that basically means I would have two constraints for the length and the angle. So kind of the length and the orientation, as well as two constraints for the x and the y. So that basically means I have to again define 4 constraints. So what this basically means is kind of with respect to what you do, you would still require 4 constraints. So the other way to do it is it doesn't matter what route you take, you're still going to end up with the same destination over here. So let's move further and then see what happens if you're looking at a rectangle in a 2D sketch. So the question then becomes, if I have a rectangle in a 2D sketch, how many constraints would I need to fully constrain the sketch? So if I have a rectangle, so I basically need 4 lines to make the rectangles, right? So essentially I have like 4 rectangles, and then if you remember, each line would probably need 4 constraints. So that basically means, do I need like 16 constraints? This seems like too many, right? So let's see why this is happening, and then it'll also kind of like lead to in the sense like what's actually happening, and then how the constraints could kind of like be redundant or not actually needed. So if you think about it, if I actually define 4 separate lines, this wouldn't really be a rectangle, right? So if I basically have like 4 lines floating all over the place, you really don't have any connections between them. So what that means is rather than having 4 lines, which would actually have like 16 points, I need to ensure that the end of line 1 aligns with the leading end of line 2. And so then same thing on the bottom here and the same thing over here. That basically means I can reduce it. So effectively what I have is actually 4 different points. So essentially you have, you can think about it, that the 4 points, you're basically defining them to be coincidental. So you have essentially like removing 4 times 2 or 8 constraints. So the other thing then is what we have then is if once we make the 4 points, 4 point coincidental, so I can kind of still have like different shapes here, right? So imagine, and then let's think about the shapes that you can actually do. So if I have the sheet and then I have 4 points and then I'm going to define them arbitrarily just to make it more fun. So I'm going to basically have 1 point here, 1 point here, 1 point here, and then 1 point here. So this basically has 8 constraints at this point, where I've defined those 8 points. And then what that means is I can, if I draw and then connect these lines, what I'm going to do is I'm not actually going to get a rectangle. I'm going to get this is actually a quadrilateral. It's kind of just like an arbitrary four-sided figure. So what I need to do to get it into a rectangle is I need to make these perpendicular. So the first thing I would do is kind of like make this line to be perpendicular. So instead of this, let's start with the same point over here. So I have this line. I'm going to make this perpendicular over here. So this is 90 degrees. And then I'll make this line to be perpendicular to the line 1. So maybe call this 1, 2, 3, 4. And then I need to make lines 3 perpendicular to line 4. So let's do this. So I make this perpendicular. So this, by the way, is a symbol for perpendicularity. And then once I do that, I have the other line. So I basically have this as the end point. So this is my other fourth line. So I want to make this perpendicular as well. So what I would do is essentially kind of just change it. And then if I made this perpendicular, so I'm going to end up with a shape like this. So this basically means I have essentially reduced the number of constraints I have. So I basically define essentially 8 constraints for the different points, and then I have 3 constraints to be perpendicular. And so this means what do we have? Um, we have basically removed this. So these are already given to us. So starting from our 16 constraints, so we had 8 removed and then 3 perpendicularity. So that basically means we require 5 are required, right? So this basically means like we need 5 constraints to fully define the rectangle. So why do I need 5 constraints? So let's see how that goes. So if I have a rectangle over here, so I can define the constraints as follows. So I can kind of tell you the length and then the height of the rectangle. So those would be 2 constraints. And then I give you 2 coordinates for the one of the locations over here. And then I need to give you the orientation of the rectangle itself. So that will basically be 5 constraints I can specify. You can kind of do the same thing in different ways, but then you will still end up with requiring 5 constraints. So let's write this down in our sheet. Um, so we basically we need 5 constraints. So we do x, y of one of the points, and then we define 2 lengths. So essentially 2 perpendicular lengths, and then we give 1 slope. So that basically means we would give, and then we'll fully constrain the sketch. So this would be our ABCD rectangle, and we are fully constraining. So notice that if you recall, I only said we are specifying 3 perpendicularity constraints. So I'm not actually saying we're doing 4 perpendicularity constraints. So let's think about what is happening over here. And then you can kind of think about why I didn't specify 4 perpendicularity constraints. So coming back, so if you think about it, the way I drew it, I basically said, so I can define like anything you specify as a constraint, you should be able to change it arbitrarily. So if I set this to be 90 degrees, this to be 90, this to be 90, there is no way I can actually set this to be, say, 95 degrees. So what that means is there is some implicit constraint in requiring the shape to be closed. That means you can't arbitrarily define, and then you might essentially end up with over constraining the object. So we basically would be full careful because there might be some implicit constraints that are already taken care of. So let's look at some best practices for constraining. So we always want to fully constrain our sketch. So that means you essentially kind of like if you change the dimension, you don't want things get mangled up. So if possible, choose built-in shapes, which makes it easier. But then for our exercise, we might actually kind of like try to constrain the sketch ourselves and then see what actually happens. These you don't have to actually follow, but it makes it easier if you kind of like define the bottom part and then you fully constrain the bottom first, and then you can kind of go in the clockwise direction and then start constraining, kind of like defining the lens, the orientation, and so on with respect to one of those points. And you can also go clockwise or counterclockwise, and just as soon as you go and then kind of look at it fully, you will define it. And if you fully constrain an entity, SolidWorks would kind of like convert the color of those lines or those points into black. If it's not constrained, you can move it in one direction or the other. The lines or the entities would stay blue. Again, these you can change. The colored settings can be changed within SolidWorks, but we'll not get into it. So we're going to assume that if your sketch is fully constrained, the entity is turned black. So let's now look at creating freehand drawings. So generally there isn't like a strong technique per se to do the freehand drawing. So essentially the more objects that you are drawing freehand, the easier things get and more practice you get and more fluent you would get to. But what you're going to do is kind of give some general feedback and general ideas how you can create a reasonably good looking freehand drawing. So the steps we'd follow is you can go through section 112 to 113 in the book, but we're basically going to be using pencil and eraser. So I kind of got this one. It has an eraser at the back. This isn't that great, so I do recommend having an additional eraser, but this would probably suffice in a pinch. So we're basically going to be using rulers to essentially do a straight edge. Any ruler will do. So I have essentially like a cheap plastic ruler that would do. And so we're going to use the rulers for the straight edge because the lines are going to guide us. And then we would kind of try to fade or kind of like smoothen the other edges. So let's see. So we're going to do a few things over here. So I'm going to basically try to create the stapler that I have here. So I'm going to try to create a 3D or essentially the hand drawn a sketch drawing here. So I'm going to imagine kind of coming up with the greatest new stapler, and I want to convey this to my colleagues and actually also convey this to my manager or the director of engineering so that we can actually try to manufacture this process. So you could potentially do like a SolidWorks drawing for this, but if it's a very quick draft idea, so you want to convey the idea using maybe like sketches. So if you look at the sketch, maybe let's look at this drawing first. So essentially we have kind of the bottom is kind of like a straight edge. This one is fairly straight, maybe at a little bit of an angle. This one is here. We have few kind of like smooth and or curved edges over here. So let's see how that works. So I'm going to leave this over here and then kind of like try to create this by hand. So this bottom edge is kind of going to be straight. So let's do the bottom straight edge over here like so. And then there is a little bit of another edge over here. So I'm going to use faint edges to kind of like guide me for the other parts. So that this is going to be the top part that's maybe a little bit angled. So I'm going to use a slightly lighter, fainter edge. And this is going to be the bottom part of my stapler. That's going to be like so. And then what I do is maybe this is like a curve. So I kind of like join this like so. And then the bottom, I kind of like fade it and create the backside. And there is probably some kind of a profile over here. And that's going to basically join to here like so. And here it's curved. And I have the stapler part over here, the metal part, which is mostly straight, and then it's kind of offset a bit like so, and then this is where it ends, and there is maybe I want to make it a little bit more fancy. And so now I have an outline, so what I can actually do is kind of the straight edges I can actually darken with my ruler. And maybe this gets darkened here as well. this one maybe I need to do it by hand. So this one by hand as well. Then this one gets darkened like so. And so these are also straight edges, so I can basically use my ruler for darkening this part, this part. And this gets darkened like so, and then this would give me the freehand sketch. So again, if it's a more complicated shape, I could have basically done this shape, where if I wanted to create this curve, so what I would have to do is these two lines are going to be straight lines. So maybe let's try to create just this top part. So this is going to be here like so. I'm going to use faint lines and then try to create this kind of a profile over here. And then because this part is curved, so I'm going to want to fade like so, and then transition to this shape. And so we would basically darken this one, and then darken this line, and then this would give you kind of like looking down this kind of a shape. So you can again practice looking at simpler shapes, and once you get more and more comfortable, you can actually create more complicated shapes by hand. Again, so this is a reasonably good technique. The other thing you want to do is maybe if you wanted to model a teacup, so again, so that actually has like a V shape, so you can use kind of like a faded edge. So this would be a teacup. So like so, this would be kind of the curved edges over here, and then the bottom, this is the top, and so this serves as my guide. And then I'm going to maybe do a freehand, and then this part is probably curved a bit, and then this part I would need like straight. The bottom is curved just a little bit, like so. And then I might have a handle over here, so I kind of like fade the handle here, fade the handle, and then once I'm reasonably confident, I can go over it as smoothly as possible again. And then once I join it, this kind of gives me like a maybe not a soup like a coffee mug per se, more like a gravy boat. Nonetheless, you can kind of create a shape. Maybe if it has more complicated shapes, you can actually fiddle around to get to that shape. So this is how you can do kind of like a really simple freehand drawing. Again, this is as you look at different objects, you can try to sketch them. The guide that again we would use is as long as you can identify straight edges. With engineering objects, you do end up having straight edges, and you can more or less create an object which resembles the object in the real world. I'm not that great of an artist, so if you ask me to draw my face or somebody else's face, it's going to look horribly bad. But as long as you're doing engineering drawings, you can kind of fake it till you make it, and then you should be able to get to the shape. All right. So the next exercise on page is it page 6? Yeah, on page 6 is going to be creating the rotated L. So hopefully you printed this out. So this kind of looks like my screen is kind of mirrored here. So hopefully you printed this L out. So this looks more like an L here. And not that difficult. So it's actually posted on Canvas. So you can print this out and then tape this together. So this would give a nice visual representation and kind of for you to get yourself grounded as to what is it that we are actually doing. So we are going to basically take this L-shaped object and then kind of like rotate it. So we start here and then kind of like rotate it and then create the different drawings. So that's what we're trying to do. So if we kind of go over here, so we're starting with the L-shaped object here. So that's given to you. And then if you notice at the bottom of the page, So I say kind of do the first rotation in this direction over here. So this I say is the first rotation. So the reason is if you kind of switch the orders, you would actually end up with a different looking L at the end. So we'll worry about that later on. But essentially, what you're going to do is kind of like rotate this. So you're going to stick your head underneath, and then kind of like try to trace these lines, rotate it further. So this will end up at about 90 degrees. So and then you get these, and then from here, starting from here, so you go rotate by 45, and then rotate it further, and then you get a shape. And then so you would have rotated 45 degrees over here, so rotate it further, and then so on. So it might be easier to start, you do 1, 2, 3, and then rotate by 45 degrees, you go 1, 2, 3, and then rotate it by 90 degrees, you go 1, and then 2, 3. So this would be a good time for you to pause the video and then do this shape, and then let's see what is it that you guys actually get. So I'm going to start out with a slightly zoomed out version so you can see the whole page. So we start out here, and then we're going to rotate it so this way. So we're going to kind of maybe rotate it by, so this is the first rotation, and then the second rotation is going to be rotating it out of the plane this way, kind of this way. So we start out here, so this is going to be up by 45 degree over here. So if I look down, so what I'm actually going to do is trace these lines. So I'm going to trace, don't worry too much about these, what is actually happening. So we'll fill these out later on. So I'm actually looking down at the screen, and we are basically tracing this. It's so let's do this line over here. Again, so you're looking down on the sheet. So then the back line over here, which kind of joins this and here. So once you have the outline, so you can just like move this aside and then make sure you have the same set of lines over here. So it might be easier if you actually use the ruler. So this one is over here, and then this one, if you actually notice, would be aligned with this line. So I know we are cheating here. Nonetheless, we do this, just double check, makes sense. And then this one, maybe mark off this point and this point, and then this line is over here, right? So let's do that. And like so. And then if I looked at this, I noticed this line actually extends a little bit further and actually meets the horizontal line I'm just drawing, like so. So let's just double check. So we have here, and then we rotate it by 90 degrees. So this is actually not that difficult to make. So we have one line over here. So maybe let's mark just the edge of this point, and then we have here, like so, and we have here, and it goes up to here, and then here goes up to here. Let's close the shape, and then I'm looking down, so I'm going to have one that's aligned with this point. All right, so we have this particular shape. So the next shape is basically taking this and then rotating it by 45 degrees, and then we're going to create this particular drawing. So for that, I'm going to cheat and then hold this just a little bit to this side. And then maybe just align my lines. Let's do this. So kind of look down. I have one point over here, and then I have another point here. This is going to be my key points. And then I'm going to look down. There's another key point over here, key point, and then key point somewhere here, and then key point over here. So let's see. So we are going from this to here, and so we're going from here, like so, and then we have, there's nothing over here, and we have kind of this shape up to here. So let's draw a line, and then like so, and then we go from here to here, and we're looking from, and then here to here, and then from here to here. So this seems to be the outline of the shape, and then we might need to fill in all of the other details. So there's one line from here, and then it goes up to here. So we go from here, and then like so. So let's just double check, and then we have another line from here, right? So seems to make sense, and then we switch, and then we're going to create this shape, and then so this one, the outline is from somewhere over here to here, and then for this side, I can maybe use this shape. And let's make it darker with our ruler, like so. See this, and then there's a line somewhere here, and then we have a line over here. So actually, then go back to here, and then we're going to flip it by 45 degrees. So that's going to be the more difficult one. So let's make sure we align it properly. And then I'm going to go 45 degree like so. So let's do this, and then 45 degree like so. And so let's see how this actually works. So let's see if I can actually plot the point. So there's going to be one key point, key point, key point, key point, and then there's going to be one key point. Kind of, if I remove my shape, so and let's see, 45. So the challenge here would be for you to make sure that you align the points back, and so it might make a little bit more sense if you kind of maybe just mark this point over here saying that's going to be your anchor point. Just put a little bit of a circle so you know what's happening, and then we have one point here that's probably already marked. So let's see if we can fill this. So I'm actually looking down. So this I don't actually see. Then there's going to be one point over here, one, one, right in the middle. So we basically have kind of a like a squished square, if you might call it, like so. And then there's a line from here. And then I think I keep moving my L so it shape changes. And we have from here like so. So we just make it a little bit nicer maybe. Gives us an idea what is happening, and then this is not that difficult to make. So this is the L. So we look, Then we have one shape over here. Right? So this is rotated like so. And now we rotate this shape from here. We go 45-degree into this plane. So we look down. So we have one like so. Okay, we might need to move a little bit further up, or maybe not. And this is here, and then this seems to be continuing all the way. This kind of a break here, and then it just gets mirrored on the other side. So let's do. And so we have this shape. So there's a break somewhere here, and then this seemed to be another line over here, and then we have this one in the middle. And we take this. Hey, we're almost there. So we take this and then rotate it. So this is going to be fairly easy to do. And so this basically completes our multiple rotations of the hair. So again, just to quickly recall, so what we did was we took this L-shaped object and I said first rotation this way, and then you rotate it out of the plane. So it doesn't really matter. So you could do this, and then what I want you to do is come back to this point, rotate it, and then stay going on. So let's see, kind of like quickly talk about why I asked you to do this rotation first rather than this rotation. Basically, let's see what happens if I did this rotation first. So I go here, and then now I'm going to rotate. I was basically rotating it this way, right, out of the plane. So I basically have my L, excuse me. So I have this L over here, and then now if I rotate 45-degree, so this doesn't seem to quite match. And then if I did a 45-degree, this is completely different from the shape I have here. So again, you could have still done this drawing. You would have ended up with a slightly different combination of shapes. But nonetheless, I wanted you to do this so that everybody is on the same page and all of our L's kind of look the same. So this kind of gives you an illustration of what is it that you can actually do. And let's see how and what does this actually mean in terms of our drawing. So again, so this is the L-shaped object, and let's see what we did. Um, so we basically just rotated it like so, and then this is hopefully the shape that we actually got. And if we didn't follow the rotation, you would have ended up with a slightly different shape. So we are going to look at some of the observations that we got from looking at the L. So I want you to kind of like pause the video and then maybe just make a list of the observations that you have and then upload it and then see what is it that we have. So let's see what is it that we did. I kind of flipped my video to make it a little bit easier. So this is the L-shaped object we are looking at, and we are basically making some observations here, right? So the first thing to note is we are actually going from what's a 3D object, and then we are essentially going into a sheet of paper, right? So irrespective of what you do, so if I give you just the one piece of information, so let's just make a note here. So I'm basically going from 3D to 2D. So if I look at this particular shape that I have, there is no way for you to figure out what if I just give you this shape, there is no way for you to figure out what the depth is kind of going in or going out. So you don't know if it's going to be like a kilometer long or it's just like maybe like a thin sheet of L shape that I actually cut and pasted it together. So what that means is you're basically losing what you could consider the depth information. So the depth information is lost. So the other thing you would notice is that you'd only see the front feature. So if I kind of like rotate it like so, or we had a few other rotations. So for instance, one of the rotations was like this. You didn't actually, if I could have kind of like maybe just nibbled at the bottom of the L, so there's no way for you to actually know unless you rotated it further and figured out what it is. So the other thing to note is we only see the front features. So the Other thing that happens is you'll notice sometimes that the features which are at different depths. So for instance, if I look at this L shape, so I have one feature which is at this depth and then another feature here. They sometimes actually seem to appear at the same depth, or they kind of like collapse together. Okay, this is kind of the same thing as saying we lose depth information, but this is another kind of the observation. So let's just make a note of this. So all of these are going to be useful when you're trying to create the hand drawing. So nonetheless, the good thing is if you look at the sheet that we have, so let's go back here. So maybe these planes, if you think about it, these are at different depths, but nonetheless, so this plane and this plane are different depth. Nonetheless, if they are at different depths, you do notice that there is a line that actually separates these two planes, right? So it's not all is not lost. So generally, if you have planes appearing together, they kind of would have a line separating them, so which is good and can mentally allow you to kind of like break the surfaces which could potentially be at different depth. So the other thing is you could actually take two views and get more information about the object itself. So what do I mean by that is if I basically look at this object over here, I can figure out how wide and how high my L is. And then if I took a perpendicular view, so I could take this guy, and what I can work out is how deep my L is. Similarly, I could have taken this view and this view, I could still work out how deep the L is going to be. I could potentially take this view and then at some 45-degree or maybe like 30-degree or 60-degree, and then I could potentially use math to kind of like reverse calculate what the depth is, but that just makes the whole calculation a lot more difficult, and it just is like super annoying to do. So you probably wouldn't really attempt to do that. So you normally would just pick like two perpendicular views. So the other thing we also notice is that the lines essentially if you're looking the lines sometimes get shorter and longer based on how is it that you're looking at the object. So let's document that. So what is it that we said? We said lines basically get shorter. So essentially if I look at this line, so as I rotate, so it gets shorter. And eventually if I look at it from the end, it basically just becomes a point. Similarly, if I think about taking this plane, so initially you see the full plane, and then if I rotate it, it essentially, if you're looking at it from the side, it basically becomes a line. So all of these could potentially happen, and the area of the planes could change, and all of that could potentially happen. So we should be aware of this when we are kind of like trying to create the view of the object, and which is kind of like looking at it at a particular angle. All right, so now let's look at the introduction to projections. So essentially, again, we talked about like what we did was essentially rotated the L, and then now what we actually did was projection. So we kind of like take a step back and then see what is it that we actually did, and kind of do it in a more formal fashion. So this is the introduction to projection. So the basic idea of projection is you have a 3D part like this, and what you want to do is take it onto a 2D surface. So the way you do that is you project, essentially you project the image of your 3D shape at different angles onto your piece of paper. So that's the basic idea behind projection. So what we are trying to do is that we are trying to project, or we are trying to cast a shadow, or we are trying to get a reflection of the object that we are trying to capture. So if you think about it, there are actually multiple ways in which you can project your object onto the sheet. So one way to project it is to kind of imagine how the viewer might visualize the object. So what do I mean by that is if you think about the L-shaped object that we have, and then you look at it from the camera's perspective, so like so, you actually don't just see the edge, so you end up the contrast a little bit bad, but what you do is you end up seeing kind of, if you think about this based on the angle that I have, you might actually end up seeing a little bit of this section and most of this section, and then a little bit of this section, right? So what that means is, as a human perspective, you don't actually see like parallel rays in a sense, because like the object are essentially casting some angle on your eyes, and that's how you kind of like perceive your distances and so on. So if you think about it, like a large tree further away might appear a lot smaller than your thumb, which you kind of could play the game, right? So you can try to obscure the moon with your thumb or a tree with your thumb. So essentially, the objects that are closer are going to be appearing bigger. And what is also happening is, because of the lines no longer being straight, you kind of perceive part of the plane when you're actually visualizing this object. So this is one way to perceive the object. So if I had this L over here and I was looking at the object as such, what I'll actually see is something like what I have here. This piece over here, which is a lot closer, would appear bigger, versus this face, which is a little bit further, would probably appear smaller. And then I'd see a little bit of this face over here. So this is the object I might perceive if I did looked at it from a person's perspective, or if I took a photograph of the object. So unfortunately, this is a little tedious and not very useful from an engineering perspective, simply because if you want to just manufacture the part, I also need to tell you where the object is placed and a lot more information. So this is just like super complicated, and you typically never do it like this in an engineering drawing. So what we're actually looking at is, or what we previously looked at is known as perspective projection. We'll kind of discuss this in a little bit more detail later on. But what we're going to be doing here is, since this is not very useful for an engineering perspective, we are going to do what's known as perpendicular projection. So we already did that. So if you remember, I kind of like took the object and then used my pencil to figure out kind of like rays going parallel to the sheet of paper, and then it hit the paper, and then I marked out those locations, and then I drew the shape. So if you think about it, what we actually did was, if we have the shape here, we would do what's known as an orthogonal or a perspective projection. So if I put this sheet of paper here, um, so I put my sheet of paper over here. So what I'm doing is I'm going to basically project lines perpendicular to the sheet of paper. So that's why it's known as perpendicular, or more technically, it's known as orthogonal projection. So if I did this, what I would see is this face just appears as a single line. This face would just appear as a single line, and then I would see this particular face. So I end up with looking at an object which looks like this. So this is the perspective. This is the orthogonal projection, and unless otherwise stated, we're going to be using the orthogonal projection in our engineering drawings. So we are going to be looking at what's known as a multi-view. Just keep in mind, the view we use is known as a third angle. There is some discussion about this in page 133 in the book. So you can look at that section. Essentially, we will kind of do a little bit more discussion on what the different angle views are, but at this point, we just keep it as such. So essentially, what are we doing here is that in the real world, so we have 3 dimensions, right? So again, since we made this, I'm going to kind of like use it as much as possible. So if I look at the L, you have the height, the width, and then the depth going into the plane, or kind of coming out based on your perspective. So on a piece of paper, though, you can only represent 2 of these views at a time. Right? So I can only show you kind of this L shape, or if I turn it around, I can show you these 2 rectangles stacked on top of each other. So there is no way that I can actually show you all these information in just one particular view. So there is no way around it. So the only kind of like a hack that we do is, we are going to, instead of using one view on a piece of paper, let's write this down. So we can only represent 2 dimensions because it's 2-dimensional. So what we do is, we use a minimum of 2 separate views to kind of represent the object. So instead of randomly throwing the views, we kind of have a visualization of how the views are set up, and that is the thing that's given at the bottom of the sheet, but we'll nonetheless go over and then see what is happening here. So if I take the 3D object, this is again the L-shaped object. So I'm looking at the object as such, and then what I'm doing is I'm essentially kind of constructing a box like this for the object. So I have a screen in front, I have a screen in the back, on the top, excuse me, on the back, the front, and the left. So essentially think about having a transparent box into which I've placed my L-shaped object. So that is going to be what I'm going to be doing. So I'm going to place this object inside a transparent box as such. So once I have this, what I do is I'm kind of like essentially think about you kind of looking at the sheet and then peeping and then kind of like drawing or creating a drawing of the shape on this transparent or translucent in this case sheet. So that's what we're doing here. So we project perpendicular to the sheet and then we kind of create the object on this particular face. So there's nothing stopping you from doing the same thing on the other face. So you can do the same thing on this face and this face and the back and then the like it depends on your perspective. So this would be, if I call this the right side of the box, this would be the left side of the box, and like looking behind would be the back side of the box. So, and then similarly at the bottom. So essentially I did the same thing and then created the different um, views on all of this. So once I do that, what I basically do is now I don't need the object anymore. I'm going to open up the box, right? So I have the box which is kind of like closed as such, and then I kind of like just like open up and then open up the top and then open up the entire box and then layer as such. And then so what I do is I kind of keep this as the reference point, and then I open the right side view, so that ends up on kind of like opening it this way, and then the left side opens up this way, the top opens up to the top, the bottom goes to the bottom of the drawing. And there is another thing, so we basically have the backside view, which is kind of ended up on the tail section over here. So this kind of looks like a plane going from left to right. You know, it's a kid's analogy. So essentially this is fairly straightforward. So essentially you have the one view over here, and then you put the top, if you're looking at it from the top, whatever you see would go here. Looking at it from the bottom would go here. Looking at it from the right would go on the right side. Looking at it from the left would go on the left side. And the back, you can't really draw on the back side of the sheet. You can, but it's not very useful. So what we do is we put the back at the kind of like further left of the left side view. So we typically don't draw these lines. So I'm going to erase these. So once I have this is how I have. And then this is typically known as the front side view. And that is kind of the reference or the main view that you basically have. So again, so what we have is this is my view, and I'm going to create that. This is my front side view, and then this is the view I'm actually creating. So this is the general way you would lay out the different views, and this is the reference over here. So what we do before we actually create the drawings itself is kind of look at something known as line types that's used in the drawing. So the reason we use different line types is sometimes you might want to represent the different qualities of the line, and rather than just like mark them out with like a pencil or ruler or kind of like a labeling system, we kind of use a specific line notation. So here is what the lines that we have typically in a drawing. So we typically have a pretty dark line, and then we have a dark dash line, thick dark dash line, and then we have a line like this, and then the rest of the lines are actually thinner. So traditionally what happens is you would use different grades of pencils to actually create these lines. So based on, you would use a 2B and a HB, and like you have a construction pencil to create different grades of lines. We aren't actually going to do that. Seems too much effort, and it is useful if you're going to be doing a lot of hand drawing to actually learn these line types. But here, and also in industry, since you're going to be focusing more on kind of creating the computer graphics drawing, what we focus on is to kind of qualitatively capture the essence of the lines without worrying too much about the actual grade of pencil. So what do I mean by that is, as long as your what I call as thick lines are thicker than your thinner lines and are thinner than the construction line, we wouldn't really deduct any points, or we just kind of let it slide. So here are the lines that we use. So the thick line, which is solid, is used for denoting features that you actually see. So this is known as visible. So this is known as thick line. So typically you would use about 0.5 millimeter thickness. The next one is what's known as a thick hidden line, which is basically like a dashed line. So this is again same thickness as your visible line, except that you basically have kind of like a discontinuous line over here. So you basically have a sequence of dashes. The next line is a long dash followed by two small dashes followed by a long dash. So this is known as a cutting or a sectional line. This again is a thick line. The other line looks a little bit similar to the cutting plane line, except that it has one long line, a single short line, and a long line. So this is known as a center or an axis line. So typically we use thin, when you say thin line, it's usually about 0.25 millimeters thickness. Again, I'm not going to use, actually I can't use a ruler to measure this, but as long as they're qualitatively thinner or lighter, it'll be fine. So the next one is again very similar to the cutting or the sectional line. This is known as a phantom line. This is used to denote the alternate position. So the cutting line and the phantom line, the lines are the same, except that the phantom line we use a thinner line. The other lines we use is known as a break. So the break line is basically a zigzag as such. If you're using this as part of the actual object or the part, then you use a thicker line. If it's used in dimensions, you would use a thinner line. So we cover this later on when you're actually doing dimensions. And then the next line is just a thin straight line. So this is known as dimensional line. So this is for dimensional lead or leader lines. And then finally, we have something known as sections or hatches, which is used, again, we'll talk about this in greater detail, just know what this is. So essentially, if you're cutting a section, what you do is you kind of like shade it. So imagine if you took a hacksaw and cut an object, you kind of see striations. So this section or this hatch pattern actually denotes those striations. So this would be a section or a hatch line. So let's try to see or mark these lines in our particular object. So that is given at the bottom of the page over here. So this is again the L that we have. So we're going to imagine this is actually the L object, and then you're actually looking at it from the back. So this is a L object, and then you're looking at it from the back. So obviously you don't see this edge, but you know that there is an edge at the back side, right? So this is where the hidden edge is going to be useful. So here what I would do is to denote, so notice this is all going to be thick, which is the outer feature. So this would be this profile that I see. And then this line that I don't actually see, which is at the back. So if you think about it, this is kind of like right behind over here. So in order to denote that, what I would do is use the hidden lines or the dashed lines. So I basically use these dashed lines mark the hidden feature. So to put it another way, if you have an object and I used a dashed line, what I'm actually saying is, hey guys, there is actually a feature behind, and if you're actually creating another view, that hidden line will be useful, but in this view there is another plane or some other feature that's obscuring that line, but nonetheless it's an important feature that you need to know. So the main advantage would be when you have a more complicated object, you wouldn't necessarily be drawing like 20 different views to show every single hidden feature. Also, you can imagine if there is a hole inside the object, you wouldn't be able to actually show it without using these hidden lines. So this is where this is particularly useful. So the next one is we're going to imagine this is actually a cylinder or a circle, and we basically are going to see what is happening. So if you have a cylinder as such, so where I do have a smaller cylinder over here, so this is the cylinder I have. So if I look at the cylinder on the side, I don't really know that there's a curvature over here, right? So if I keep rotating the cylinder, it's just the element, or this still seems to be appearing, and irrespective of how I actually turn the object, there isn't really an edge. Nonetheless, if I actually didn't draw an edge, or when I took the photograph or projected this, I actually do see some sort of an edge. So in this perspective, this is actually known as a limiting element. So we'll mark this out. So these two lines are known as limiting elements. They actually correspond to the top and the bottom of the cylinder over here. So again, the basic idea is that these are needed to actually represent the object, but unlike an actual physical edge, they don't actually exist in the true sense. So they're not really edges or like hard delineation on the object. So they are known as limiting elements. So if I look at the other side view, so if this is depends on how you're looking at. If I'm looking at the object like this, and then I look at the other side view, so what I would actually see is a circle. So generally for a circle, the center is very, very important. So if I wanted to mark the center, so I could use a pencil and mark it on this case. If I just draw a point on the circle that I have here, so I know where the point is going to be, so I know this is where it is. So to actually mark the point, it's going to be rather difficult. So rather than the point, what we do is we use the center axis line. So we draw one vertically and one horizontally. So this indicates that this point here is the center. And then to actually denote that this is actually a cylinder and to denote the axis of symmetry, we again use the center axis line. So we basically would create an axis line as such. And this is how I would create it. So I can, instead of giving this length, so this cylinder doesn't have any interesting feature, what I can actually do is like shrink the object. So I can actually move these faces together and basically save space. So in this case, what I would do is use the kind of the zigzag line. So I can actually draw this face, and then I can potentially also draw a dimension. So we'll cover this at a later point. So this is what we would do in our case. So the next topic is to actually look at the grid sheet and then actually create our drawing of the L as well. Here is what we have. So I'm going to switch to my other camera and then look at the bottom of my paper over here. Um, so, so here is the object. So this is the grid sheet that we have. So we can use here, this is known as a rectangular square, excuse me, a square grid or a Cartesian grid. So if you look at the object itself and then I measure, so the way the grid is set up, and I've also uploaded this to Canvas that you can use to create your drawings. So this is kind of, if you use my ruler, so you notice that between these two lines, or between this line and this line, so the distance is 1 centimeters or 10 millimeters. And then similarly between this line and this line, it's again 10 millimeters. So this is essentially like a 10 millimeter square grid. So again, typically we don't use this in a professional drawing, but in our case, it's going to be useful to kind of quickly get a feel of how the object actually looks and to actually make measurements and make sure everything is done correctly. So what I do also recommend that you get like a set with a compass, a protractor, and so on. We wouldn't really be using it, but particularly if you want to draw circles, this makes it a lot easier and a lot nicer. So this actually I got this. This is fairly inexpensive. It's called a geometric set. You can actually get it anywhere. So maybe I should put like a referral link to Amazon or something and then make money out of it. Anyway, just Google it, and I actually found one in the dollar store, so you can probably get that too. So we're not doing, so if you're doing professional level drawing, I do recommend additional like a protractor and like a really good quality French curves and so on. But most of our more complicated drawings will be done on SolidWorks, so this level of stuff is okay. And you might still get away if you have very good artistic skills or your hands aren't very shaky. You might get away with actually using free drawing your circles and free drawing your curves. As long as it doesn't look horribly bad, we are going to let it pass and it should be okay. but nonetheless, the protractor and rulers would be something good to have. And I just happened to open this and notice that the ruler is actually a lot nicer than the one I got here. So this actually kind of like loops around, and it has millimeters on one side and then centimeters on the other. Um, and just that since it happens to be a dollar store, the readings are starting to get erased, but that's okay. It still looks decent. All right, so can I unlock this? Okay. I kind of maybe prefer using one common ruler over here. Anyway, so coming back, so what we're going to be doing is looking at this object, and then we're going to create our projected views. Again, so this is the same as the object that we had before, just that we're not always going to be having this object kind of like rotate and see how the face actually looks. So we're going to figure out a different way to actually draw the object. So essentially, if you think about this object, so this is known as the front view. So this is the front view of the object, so like so. And then the view that we put to the right of the front view is known as the right side view. So the word side is kind of common, so you might just call it as a right view. And then what we do is we can actually create another drawing on the top, looking down at the object. So whatever comes here would be the top view. So obviously I can put my front view here, and then the right view over here, and then the top view somewhere in my neighbor's notes. But that's not very useful. Typically what we try to do is, because there is going to be some relation between the objects, we are going to try to align the views as much as possible. So what do we mean by that? Is if you imagine I have the front view over here, and I look at it the right side, so you can imagine what's going to happen, right? So because of the way I'm rotating, this feature, which would be the height feature, is going to stay the same, right? So let's kind of just make a note on our sheet and the top of the sheet over here. So what we're saying is we have what's known as the front view over here. So the question then becomes, how do I actually select this particular front view? So generally we pick the view with the most amount of information or most interesting feature as the front view. So typically the front view has the most important feature, or it could have the longest dimension. So either the most important feature or the longest dimension, we would treat that or call that as the front view. So once you have the front view, so this would be my front view. So if I look at the front and the right side view, so I can make some comments, right? So the front and right views, so what are they going to share? So they're going to share this, which I call the height of the object. So these are going to share the height feature. And similarly, I can do the same thing between the front and the top view. So if I think about what's happening, is this is my front view, and then if I look at the top view, so this, because you're rotating about this axis over here, this length is kind of going to be the same, right? So if you think about the front and top views share the length, or you can call it the width of the object, but we just call it the length feature. And so generally what you want to do is, because they share the height feature, you would basically want to align the front and the right such that you can actually identify the height features easily. So you want to, like, so if you have an edge which appears at a particular height, you want it to be at the same level. So it makes it easier to view. So we leave a little bit of space here. We're going to come back and add one more thing over here. But this is my object. So this is 20 millimeters or 2 centimeters. And then I'm going to draw the right side view over here. So for that, I would use the construction line. Here I already have my gray lines as a construction line, but nonetheless, it might be useful to just maybe do maybe just half a shade darker. I'll pull these lines over here, so hopefully you can see them. So again, pull this guy all the way to infinity and beyond. And then we do the same thing with the bottom edge over here as well. Right, so essentially what I'm doing is I'm saying, hey, these are features, and then based on where I'm going to be drawing the right view, this could go all the way. After I create the drawing, I might want to erase some of it in case I need space. So then we're going to do the right side view. So the actual location of the right side view is arbitrary. So if you think about the box example that we previously had, the actual location kind of depends on the size of the box and then where inside the box this L is being placed, right? So that basically means I can put this anywhere. So generally I would like to leave a little bit of space. So I maybe leave at least like 20 or maybe like 30 millimeter space. So depending on how much you want to space it. But in this case, if you want to make it, so you definitely don't want to put it here, just leave a little bit space. So maybe we draw it over here. So technically you cannot draw this information just based on the front view itself, but since we know the depth of the object, so we're going to use that information to create this drawing over here. So here, and then what do we see in the front view? So we kind of can create this, like make it significantly darker, and we see the line here. So this is what we see. So if you look at the L that we previously had, that we basically created from the rotation, so this is same as rotating by 90 degrees, right? So that's what we got here. So we do the top view. So essentially what we do is I'm going to do a similar thing because the top and the front view are going to share the length information. So I'm going to basically just mark out the length features all over. So expand this, extend this, and then this kind of gets aligned here. So we kind of extend this all the way. So I do apologize if the lines aren't quite aligned for this particular exercise. We're going to assume they're aligned to the grid lines over here. So once I have this, so again, looking at just the front view, I don't know how deep the object is going to be, but nonetheless, I'm going to just leave maybe like 2 centimeters or 20 millimeters gap here, and then recreate the top view over here. So we leave 2 or 20 millimeters, and then we have this, and then we have our objects like so. And this is our top view. Again, the bringing back the sheet that we previously had. So essentially, if we take this object and then rotate it by 90 degrees, so essentially we get the top view. So this again is the top view. So far so good, right? So essentially we have this view and this view. So now there is something that's curious, right? So if you think about the object, so it's 20 millimeters deep over here. So it needs to be 20 millimeters deep over here as well. So essentially, the top and the right view actually do share the depth information because it's still the same object. But what's actually happening is that it's being rotated by 90 degrees, right? So that's what is happening. So we'll kind of maybe we'll make a note of this. So we are basically saying that the right and top views, so they share depth information, but this is rotated by 90 degrees. So just to make it a little bit clear as to what is actually happening, let's use some notations here. So I will use kind of like a circle with a dot for an arrow coming at you. And then we can use kind of like a circle with a cross to go denote an arrow going away, going away. And then if I look at the same arrow on the side, so that's going to look something like this, right? So this is the arrow we are looking. So again, so we're going to use that to kind of like illustrate what is actually happening here, and so we know that we are on the same page. So we are going to look at the length-shaped objects over here. So I'm going to use kind of like explain what's happening here. So I'm going to draw my arrow in this particular view, right? So this is my arrow. I'm going to imagine it's going from so this is actually going from the front of the object to the back. So this would actually be the front face. So again, this is going to be more useful when you're actually trying to create. So this is the front face, actually creating what's known as a missing view. But nonetheless, so essentially what's happening here is this arrow that we have is it doesn't matter where it is at this location. So I'm going to imagine maybe the arrow is located over here. And then what I'm actually looking at from the front view is the arrow going into the plane. So essentially I'm looking at an arrow that's going into the plane, and so if I keep the orientation correctly, so I have the arrow going into the plane, I rotate it like so, and the arrow is going from left to right. So this is what we have to be aware when you're doing this. So let's see what happens to the same arrow when I rotate it um, to go into the top view. So my arrow is going into the plane, I rotate it. So the arrow keeps traveling, just that my camera is rotated. It's going to be a little bit complicated to kind of like rotate my camera um, to here. So I'm going to assume that my object is kind of being rotated. So anyway, so this is going in. That basically means my arrow is going to be traveling in this direction over here. So maybe just to make it easier, I'm going to align my arrow here. So this is going to be the tail of the arrow. So what this means is that this is going to be the front face, right? And then this would be the back face that is big. So what that means is this again illustrates what we wrote down, that the right side view here and the top side view actually share the depth information. So you can think about the arrow going into the plane. So, and then this arrow is kind of going this way. So they actually share that information, but then it's going to be rotated by 90 degrees. So this is kind of useful to remember. So I have an animation of this feature over here. So you can think about this arrow. I'm basically just like translating or kind of like rotating about the axis to get to this point. So the next object we're going to be drawing is, I'm going to call it the L bitten off. So essentially it's the same L-shaped object that we previously had, just that somebody kind of maybe took an hacksaw that kind of took a bite out of this L-shaped object over here. And that's kind of, so this is the L that we have, and then somebody's taken a bite from the back side, which is something you don't actually see. So we create that object over here. So to imagine how is the object going to look, so essentially we have this object and then somebody has essentially taken a bite from the back side over here. Right? So we can imagine how the object is, and then just to make life a little bit easier, so I've actually given you the L-shaped object over here, and then we're going to create the missing here. Since the kind of, I'm going to assume it's at an angle over here, and let's assume that it's kind of like maybe 20 millimeters over here. Because it's a hidden feature, so what I'm going to do is use like dashed lines. So this is how I would do the hidden lines. So this is my hidden feature over here, and then my front, sorry, this is the front view. And then for my right side view, so I'm going to assume it starts somewhere here. So I'm going to draw this line going off to infinity, this line going off to infinity, and then this line going off to infinity. So we kind of create our L again. So this is going to be the front face, and then this is going to be the back face of the L. and this part doesn't really change. So here what's actually happening is you can think about the L going halfway, and then this you're going to see, like if I'm looking at the object like this, I'm going to see this edge, right? So I'm going to see that edge face on, so it ends up looking like this. So essentially, I have kind of, this is my object, and then when I turn it around, what I'm going to see is kind of like a flat edge. So that's the reason I see this. And then what I would see then is this edge actually shows up as another half edge over here. So what do I mean by that is I'm going to kind of like create um, another line here, here. So in my drawing, this would actually look like a single continuous line, but we have to be aware that these are actually at two different depths. So there's one here, and then there's another one below it. So they're actually at different depths, but because I'm looking at it in this direction, I only see this particular view. So what you're going to be doing now is use the fact that the right side view and the top view are sharing the depth information, and the front view and the top view are going to be sharing the length information to actually construct a top view. So to put it in another way, the size of the top view isn't completely independent. So let's do and then see how we can actually do that. So this is fairly easy, right? So I'm going to basically just take these lines. So this goes off to infinity, and then this is another feature that's going to show up. So I'm going to take this all the way to infinity, and then there's going to be this feature of interest. I'm going to take a line and take this off to infinity here. So then the question is, how do I actually get or transfer all of these dimensions over here? So one way to do it is I can go with a ruler, measure this, and then try to transfer it here. But that gets pretty tedious, particularly if you have more complicated structure. So what I essentially want to do is rotate the view really easily by 90 degrees, right? So essentially I want to kind of like rotate it by 90 degrees. So for that, what I'm going to do is mirror it about a 45-degree line. So if I were to draw a 45-degree line, so 45 would be here and then pass to this point. So I'm going to draw a construction 45-degree line. So here again, so this line could be anywhere. So just as long as it doesn't interfere with the object, it's fine. So I can actually move this up and up. But here I just like to put it going through this particular point. So if I do this, so if I imagine taking a reflection of this for this pen, it's going to end up pointing this way. So again, if this were my arrow, doing a reflection would go and then go up. So what I'm going to do is go up to the 45-degree line. So this is known as the mirror line. Or, I mean, if you wanted to use, there's actually a formal name for this. So this is actually called the M MITRE line. Let me just double check the spelling here. Yeah, it's MITRE line. So this is also the mirror or the 45-degree line. So anyway, so how do I use the line? So I'm going to go push this depth up to the point on the 45 on this miter line, and then what I'm going to do is wherever it hits, I'm going to draw a horizontal line. So essentially, I go and then turn the corner. So I'm going to draw like so. I'm going to extend this line over here, and then the other feature is going to be here. So I'm going to go and then create the hit the miter line, and then turn the corner, and then we go all the way over here, and then we go up to this point over here, and then turn the corner, and then like so. So once we have this, it's going to take a little bit of practice to get a hang of what's actually happening. The easier way to do it is to kind of maybe do like few lines at a time, but we've already drawn all of these lines just to illustrate the process. So let's see how we would actually do it. So we wanted to take this particular face, so that corresponds to, so I'm going to basically use this and then this. So wherever these two lines intersect, that's going to form the top face. So that's going to be this 4 points over here. So let's make this darker. Right, so this is this face, and let's see the other face. So we are only looking at this face, so let's look at how this comes about. So this, what do I do is I can take like, so this is going to be like two parts, right? So I can take the one that's closer to me is going to be here. So it's going to be all the way. So I'm going to basically be, so the line so because this is hidden, so that's going to be further away. So this bottom face that's closer to me is going to be coming from this and this line. So I'm going to make this darker. So this is what we do. And let's look at, okay, so this is going to be darker up to this point here. Then if you find this is a little bit darker, we can just erase this off. And what about this line? So because this is hidden away, so this line actually is going to be corresponding to this line. So from here to here, like so. And then there's going to be this line, which is kind of going into the plane over here. So what do I have in that case? Is I'm going to have a line here, and then I'm going to have a line here, which goes like so. And then I'm going to have the back face here. And then looking down, I'm going to see this line as a face, which would correspond to basically between these 2 points and then this. So that's going to end up here. And then we end up with this particular shape. So when you finally draw it, it doesn't look as complicated. So just make sure that, so the only thing to note is that you don't have any line over here. So if it looks a little bit darker, you just use the eraser to erase that off. So this is how you would draw the L bitten off. So this basically concludes our week 2 of MSE 100. So what we did was we actually covered a couple of different things. So we started off by kind of like jumping back and looking at the constraints that are used in our engineering drawing or in basically SolidWorks. And then we looked at how we constrain a line, a point, and all of those things. And then what we did was we basically switched gears into actually creating engineering drawing. So in that, what we did was we basically took an L-shaped object, rotated it, and then projected and created a drawing. So they gave us an idea of how the objects could be rotated, and then how, um, uh, if you're looking at a rotated object, what is it that you actually see? And then once we did that, what we did was we said it was impractical to draw like 20 or 16 in this case. Actually, it was like 9 views to represent even the single object. Instead, what we do is we basically would need 2 views. So one would be, typically you would pick the front view because it has the most information, and then give either the left or the right side view and then the top view. So that will basically give you all of the information that you would need to construct the object. So we, just for an exercise, we kind of created the different views and then saw how the object actually looks. And then what we did was we basically said, what happens if I'm given only the front, and so I'm given only the front, and then there's a piece that's bitten off from the back. So I have those two views. Then we looked at how we can construct kind of the missing top view, or kind of construct the top view using the information that's only available in the front and the right side view. So this basically concludes our video, and hope we'll see you all again in the next lecture. Thank you.